Alrighty, ladies and gentlemen, we are back at it again on Snowblower motor. The hone I picked up that was readily available today, because I showed you last time, the cylinders are completely shot. There's absolutely no cross hatching whatsoever in them. So we're gonna wipe those out before we start honing it. We picked up this little unit from Horrible Freight. We're gonna see how it does. I don't know what grit these pads are. I'm assuming they're like 220, but it should be not awful. Just keep them lubricated and keep your drill speeds down, like 600 to 800 RPMs, I think, will be good for something this size. And we're going to use WD-40, not motor oil. Should work just fine. Keep the drill speed down. We'll check. We'll do a couple, and then we'll check. And we'll see if we have to slow down or increase our drill, like slow down the stroke or increase our drill speed. So we'll get this going. It's going to be sort of a two-handed operation for me. So I'll have to put the camera down, and I'll start it, and then if it looks like we got it, I'll show it to you guys. Alrighty, so the cylinder is honed, and I know there's going to be people saying on this video you shouldn't hone aluminum cylinders, and it's not advisable, honestly, but it was so taken down and smooth, I just wanted to put a little bit on it. And it's not perfect, but it's not bad. It's not perfect, but it is certainly not the worst. There's some 45 degrees scratches in there. Most of them are a little steep, or a little flat, I should say. But I think we'll be fine. And next thing to check was piston to sidewall clearance. So you notice how you stick this in? That gap has got to be right. And Tecumseh's service spec is like 43/10,000ths of an inch. And this is 40 thousandths right here, which goes in and gets a little stuck. But it goes in. Ideally, you should be measuring it several places, but it goes in. And now we'll just set you all down super quick while we switch it over to the 50 thousandths, which I know is 65 larger than the service spec, but doesn't really want to go in. Let's keep that correct. It does want to go in over here though. So the cylinder is not perfectly round. But the machine, so I have mixed feelings about honing the cylinder. It's already done. It is aluminum, and it wasn't burning a ton of oil. Actually, no, that's not true. We don't know if it was burning oil. There was no oil in the motor. So we don't know. We don't know where it went. It wasn't leaking oil, I can tell you that. So it must have burned it out slowly. So maybe this is still a good idea to hone this cylinder. But you can see it doesn't want to go in. It goes in just a little bit, and then it stops right there. So that just means the top is really worn on the compression stroke. And that's all there is to that. So the next thing is I got to run to the hardware store and get some more head bolts, which is nice because they're just grade 5 standard bolts. I got to get a new screw because I haven't done that yet. And I think we're just going to clean up the spark plug after all because I don't feel like buying another one. So we're gonna do that and get this motor buttoned up tonight so we can install it tomorrow and give the silicone a night to seal. Okay guys, we've got the crankshaft connecting rod, that's all torqued down. Now we're starting to put in the lifters, which are technically these, and camshaft, and the oil slinger is on. So we just got to get the camshaft in, and then we can start. Got to clean off a little bit of gasket material on that, but then we can put all this together with a gasket and some silicone, get that torqued down, and then I can start putting the rest of it together. So we'll get the cam all cleaned up, we'll get our lifters installed, and they're marked intake and exhaust because they wear to the lobes. And yeah, pretty straightforward process, pretty simple engine. Not the first small engine I've done though, so we'll just keep trucking. Just bringing you guys a little closer up to speed. This is how far everything is put together. We put in hex socket style cap screws here, but they were a little big and I sort of forced them to fit. We put a small crack in that, but it's not like it's going to cause a vacuum leak. And yeah, it's just saying if this carburetor ever has to come off again, I'm just zipping off these screws right here because they're not studs. If I loosen up that nut, it'll spin. So we're just going to zip those off, take that off, take those cap screws out. Then probably have another one of these made to take this style of cap screw, because that one is pretty old and beat up, and honestly I'd want one made out of steel. This one's out of aluminum. If we make it out of steel, I can just weld studs on the back for the carburetor. But I don't think this motor is going to be worth it when it comes to that, because we're right at the limit for the piston to bore clearance. But if it's still kicking around, we'll just get an oversized piston and call it good. I still got to torque these down. It's RTV'd, but we're just waiting on we were waiting on it to tack up, and now we can just torque those down. We got to get some of the throttle, ignition, and starter components back on here. But other than that, it's going pretty well. So I will we'll keep plucking away at this. We got to put the starter or the drive pulley back on this guy. I don't remember exactly which way he faces, so we gotta look that up. Good thing we take pictures before we take everything apart. But I'm just gonna keep plugging away. I don't know if I'm gonna put the head on tonight. So the head bolts that I bought, the threaded portion is too short. I have to buy fully threaded bolts. I don't necessarily need the head on tonight. So I'm probably going to wait, return those bolts, get fully threaded bolts, and then put it all on. But I got to wait to put the fuel tank on then, because that's bolted on with the head bolts and all that stuff. But I can get everything except the fuel tank, and I'm going to save on a couple covers too, so those don't have to go on. Especially this one right here. This is held on by head bolts. I believe it goes on like this, or like this, like this. This is how it goes on. So that cover goes on with head bolts, so we're gonna have to wait on that too. But other than that, it's going pretty well. Of course, we won't know how good it is until we fire it up for the first time. But yeah, so I'm just gonna keep putting stuff on. I got ignition timing to set and all that. And we'll get it most of the way there, and then we'll call it quits for the night. Okay guys, if you work on snowblowers a lot, I'm sure you'll know this, but I did not know this. This is how you set timing. It's kind of interesting. I have my magnetic base indicator gauge. Right now it's zeroed out at top dead center. And the spec, because it's a 2 3/4 inch bore, the spec for this is set at 20 thousandths gap. And I have my feeler gauge out right here. So you set the point gap at 20 thousandths right there. But there's no degree. You set it at 80 thousandths before top dead center. And it really shouldn't matter what stroke, considering it runs on the crank. At least that it shouldn't in my brain. But I just think that's kind of weird. Well, not weird, just different. It's kind of cool, unique. I've never set timing with the dial indicator before. So we have our jaws of life. And right now we're at top dead center on the compression stroke, just before the power stroke. So the motor turns so now we can actually get it to perfect top dead center. So that's where I had it set, but it's not quite perfect. We are about 1/1000th of an inch off. That's perfect top dead center right there. We'll just recalibrate the dial, zero it in. So that's perfect top dead center. Right there is perfect top dead center. And I know it's 80 before top dead center. I keep looking at this thing. So pull start. Because it mounts on the motor like that. Also using head bolts. And then when you pull it, it spins that way. And that means that the motor, when facing it like this, spins clockwise this way. So before top dead center, we have to spin it that way. 80 thousandths. So we're gonna look at the tiny little red numbers. You know, just to show you on the side. We're gonna look at the tiny little red numbers. And right about there is where we need to set our 20 thousandths gap. According to the thing. But that can't be right. Look at that, it's not even close. Oh, well, I suppose it's adjustable there. That is the spec, and we'll know if I set it correctly tomorrow when I try and start it. But I mean, that looks like all the motorcycle points I've ever set. You set it to the timing just before the thing, but those all have adjustable lobes and then run off camshafts and all that. So we'll bolt down the whole assembly. We'll adjust the point on the slot right there. And we will get it set right at 20. And then we'll spin the motor over and we'll see if we think that's right, because that looks like it's going to open up real fast. But I'll take a peek at it. Okay, so we were setting timing, and I think I finally figured it out. We've got the multimeter out to test for continuity. Normally I'd have a test light, but there's no battery. There's no battery on the system. We are testing between both sides of the points. The instructions say, the manual that I don't have, says you turn the crankshaft till the arm for the breaker points is on the high spot on the cam. You set it to 20 thousandths, and then you turn it to 80 thousandths before top dead center compression stroke. And then you set the points so that it just breaks the circuit. by moving the whole stator assembly. Now, that's really, it's not that bad. That's pretty much all we're doing. Right now, with how the stator is set, the breaker points open at around 30 thousandths before top dead center. So we're just a couple thousandths off, 50 thousandths off. But yeah, that's adjusted by moving this. And the reason we have to get the timing perfect now, we have to get this, the only way to set this is static timing. There's no timing marks or anything. But we have to get static timing perfect the first time, because I don't want to do it again, because I got to pull off a bunch of covers, that thing, which means I got to take the head bolts off, which means I really got to take all the head bolts out so the head doesn't warp. And then I know it's a small head, but I don't want to take any chances. And then I got to press this off again, or pull this off. And then we can set the timing again. Then we got to do it. I don't want to do that a couple times. So we're getting it perfect the first time through. And it is a multi-handed operation. I don't have enough alligator clamps to make it easy. So I can't really record this. But it is going well. You have to disconnect the leads too, so that they aren't grounding out. Otherwise, you'll just always have continuity, because it grounds here, and you'll always have continuity running through the system. So you disconnect your leads, do all that. You get your dial gauge. You can use I suppose you could use a vernier calipers. Set it to 80,000th step, and then you could figure it out that way, going off the lip of the top of the block. This is just easier. This is a much nicer way to do it. Yeah, so I'm just going to get back to it. We'll get the points covered. And this is probably my favorite part. This whole thing is this points cover, because it says, I don't know if you guys can read that, but it says Tecumseh in cursive. And it says set points 20. That's something I've seen on 60s cars. That's a nice, and this thing is from the 80s. So that's a little detail that I really like, is that. Makes it seem a little more vintage, which is more my style. But everything looks fine. The motor spins really nice. I can spin it by hand, butter smooth. I haven't felt anything, heard anything. So my biggest concern is those rings with how worn the cylinder is. But I'm hoping it'll be fine. It didn't leak oil before, so I'm not sure why I thought I should hone it, but I did. So, or it didn't burn oil before. But we don't know if it didn't burn oil before, so all that jazz. You know the story. So we're just going to loosen up these two bolts, 7/16 socket, spin that until the points just break at 80 thousandths BTDC, and then we'll button her up, and we will get both sides of this on, and we'll call it good. All right, this is what we like to see. Have it disconnected so there's no continuity. And we have it. So right now the points are closed. So you can see when we touch the points. When we touch the points together, you can see the needle jump on the voltmeter. Right there. That's just touch and needle jumps. Right there. Let's see if we can't get a better angle. Touch, needle jump. Touch, needle jumps. That means there's current flowing through. So I'm going to try and do this. Right now we are at 88. And right now it is set that it breaks. Right now the points are closed, and it breaks like right there. Just a hair, but that's enough. Oh, I may have spoke too soon. So we still have continuity. We go just a little more. Should be fine now. Nope, okay. Oh, nope, look at that. That's the problem right there. See, it's grounding out. Can't have that. What the heck did I do to shift it over? That's not possible. How did it jump like that? So now it's not broken. Okay, 1 second. Okay, so literally as soon as I stopped recording, it started working again. There you go. We are at 20 thousandths. I'm tapping it right now. We're touching. Nothing. But let's back it up a little bit. Oh, sorry, let's bring it forward a little bit. But let's just say that much. We touch. Oh, that's right. I'm getting backwards. It's late. So we go back 3 thousandths. We touch. We have continuity. Let's only go back 1/1000th of an inch. We touch. Nothing. So really we're at 81 thousandths before top dead center, maybe. Let's go all the way to 2. Yeah, and at 2 we touch. So we're at 81 thousandths before TDC, which is honestly perfectly fine. That's good enough for me. It's like getting dwell on an old V8. Get the dwell just right. You don't have to get it, 29 degrees, 31 degrees. As long as you're within a degree or so, I'd say you're good enough. But we've really tightened it down now. Let's double check. We have continuity at 82 now. Let's bring it all the way forward to 80. No longer have continuity. Oh. Well, yeah, when I touch that part, we do. No longer have continuity. So, works for me. We'll get the rest of it buttoned up. All right, so we finally buttoned it up. I did run the old head bolts because all the full thread bolts I could find in this size were grade 2, which is not good enough. So we just used the old head bolts, which is fine. And she's all buttoned up and ready to go on the mower. All the lines are hooked up. We had to make some electrical repairs. And there is new bolt down here as well for the fuel tank mount. And this motor can take electric start. So in the future, if I feel like it, just take that cover off and the starter bolts right here. You could add it, but probably not, because there's really no reason to. But yeah, so you just gotta run this back home to the blower and get her all bolted down and hooked up. Overall, it went pretty well. Now I gotta torque the head bolts down. They're in there loose right now, so we'll do that and get her put in.